Okay, so in this video we'll be looking at the differential of logarithmic functions in this time. So the first thing to notice, a bit of notation, is we naturally use ln x for when we mean the log e of x, okay? So that is log to the base e of the x, okay? So we normally just use ln x for short, okay? But when we use that, we do mean this here, okay? So the first thing to note, okay, is that the log of x and the e to the x, okay, the exponential of x, are inverse functions of each other. Okay, you should have maybe known that from higher. Okay, but these two are inverse of each other. So that means if I want to take the log of the exponential of x, I get the x back. Okay, it's vice versa. It means if I want to take the exponential of the log of x, it means I get the x back as well. Okay, they're inverses of each other. So the rule is when we differentiate log of x, okay, the answer is 1 over x, okay. There is a proof for that, okay, which I will show later, okay, but if we differentiate log of x, we do get the answer 1 over x back out. So that's my rule, and that's what I'm going to use when I differentiate log functions. Okay, so let's have a look at a couple examples in this video. So the first example we're going to look at, okay, is this function here, okay, so I'm going to differentiate log, okay, of x squared plus x plus 1. Well, the rule states that I just simply put 1 over what is in my bracket here. Okay, so that's going to be the first part. If I differentiate this, I get 1 over x squared plus x plus 1, which is what was in my bracket here. However, I do need to remember the chain rule concept, and that means I need to multiply by the differential of what's in this bracket here. Okay, so if I differentiate this bracket, I'm going to get 2x plus 1. So I need to remember I am multiplying by 2x plus 1 on top of this fraction here. So it just goes on the top. So my final answer for differentiating log of x squared plus x plus 1 is dy by dx equals 2x plus 1 over x squared plus x plus 1. Okay, so that's an example to illustrate how this formula works. So we just go 1 over what's in our bracket, and then remember we need to multiply by the differential of what was originally in our bracket as well. Okay, so that would be the final answer for the first example. Okay, let's look at a second example, a bit more involved, and it will be a quotient rule. So we're going to look at this example here. We're going to try and differentiate log of x over e to the 2x. Okay, so I'm going to let u equal my log function, my log x, and I'm going to let my v function be e to the 2x. Okay, so that's what I've got written on the right hand side. The quotient rule means I need to differentiate both of these. I need to use both of them in it. Okay, so if I differentiate both, well, if I differentiate log of x, okay, then my rule says I get 1 over x. Okay, so du by dx is 1 over x. If I differentiate this, well, if we've watched my exponential video, then we get the same exponential back, but I need to multiply by the differential of 2x. The differential of 2x is 2, so it's 2, then the same exponential, 2e to the 2x. Okay, so that's my du by dx function and my dv by dx function. So I then just go straight to my quotient rule formula. Okay, so that's my formula there. Remembering I've got a v squared that I need to divide by. So v times du by dx, well, v times du by dx means I'm going to get e to the 2x over x. Okay, I need to subtract u times dv by dx, so that's going to be log of x times 2e to 2x, so that's going to be 2e to 2x log of x. Okay, which is what I have got there. Okay, now remember I need to divide by v squared. This is my v, it's e to 2x, so if I square that, so it means e to 2x times another e to 2x, you add the powers, 2x plus 2x is 4x, so it's e to the 4x there. Okay, now again that's my answer, however it's nowhere near neat enough. Let's see if we can rearrange this to suit it neater. The first thing to spot is I don't have something nice as my numerator. I've got this fraction that's here as my numerator. How I can get rid of this divide by x is if I multiplied every single thing in my fraction by x. If I times this by x, x will disappear, which is good, but I need to remember to times everything here by x as well. Okay, so I'm going to do that first. That'll make it look slightly neater. So that's what I've done there. I've multiplied everything by x, the fraction goes away there, and then I've added an x to this function here, got it there, and I've added an x to the denominator as well. Okay, I now can take a common factor of e to the 2x out of this top line, this numerator. So that's what I've done there. So I've got that as my answer so far. I've got e to the 2x outside a bracket of 1 minus 2x ln x. And the last thing I can do is I can divide both top and bottom by e to the 2x. Okay, so if I divide that by e to the 2x, that e to the 2x will disappear. I'm left with my numerator as 1 minus 2x ln x. If I divide my denominator by e to the 2x, okay, it's going to give me x. Take 2x's off the 4x's will give me another 2x's, so it'll be e to the 2x on the bottom. Okay, so I get that as my final answer, 1 minus 2x ln x over x e to the 2x. Okay, remember ln x just means log of x. Okay, so that's two examples on the differentiating the log. Key thing is our rule, and remembering we need to remember the chain rule concept as well. So we always multiply by the differential what's in the bracket before we go on. Okay, thank you.